Welcome, dear students. So today we are going to see a method of direct energy conversion, that is magneto hydrodynamic power generation. So earlier we have discussed about one kind of direct energy conversion, that is solar photovoltaic energy conversion, that is from light energy to electricity. So any primary source, when it is converted directly to the useful source, can be used as such, that is electricity. That kind of energy conversion is termed as direct energy conversion. So another method of direct energy conversion is thermoelectric effect, using thermoelectric effect, Seebeck-Peltier. So today we will discuss about magneto-hydrodynamic power generation. So let us begin the session without delay. In this MHD system, magneto-hydrodynamic power generation system, thermal energy is converted to electrical energy directly. It is based on famous Faraday's law of electromagnetic induction. What is that? When a conductor is placed in a varying magnetic field, the voltage difference, the potential difference will be induced. So it was first introduced by famous Micheal Faraday during his experiments in 1832. So whatever he found, he was presenting to the Royal Society. I'm sorry. Yeah, now it is correct. This is the principle of working of MHD system. So magneto-hydrodynamic, that is MHD, it is concerned with a conducting fluid. So the working fluid will be a conducting or ionized fluid flowing in a magnetic and electric fields. So a conducting fluid will be allowed to flow under the influence of a magnetic and electric fields. So difference of an MHD system from a conventional generator is that the MHD system is a hot ionized gas replaces by the solid conductor. So in a generator, alternating current generator or direct current generator, DC or AC generator, we will be having a solid conductor. But here we are having a ionized, hot ionized gas, that is the conducting medium. So there are no mechanical moving parts. So we can avoid so many disadvantages of the conventional electric generator systems. So this is a simple explanation of the system. You have a conduit or passage for the hot ionized gas to flow, and you have the side walls. Okay, side walls are nothing other than an anode and a cathode. Okay, and there is an external circuit to which you will be getting the electricity, and the magnetic field will be applied in a direction perpendicular to the flow of the hot ionized gas. You can see the direction here. The applied field is in a direction perpendicular to the flow of the ionized gas. Yeah, this is another simple line diagram. You can see a hot ionized gas will be given, magnetic field will be perpendicular. This cross symbol represents it is perpendicular to, this is perpendicular to the plane of the this screen. Okay, this is a duct. So obviously of varying cross section, the current will be generated and it will be given to the load. So we need to have a duct, then an anode and a cathode, a magnetic field. So for producing magnetic field, you may require magnets, strong magnets, then an external circuit to take out the generated power. So a pressurized electrically conducting fluid, that is ionized, hot ionized fluid or gas, flows through a transverse magnetic field in a duct. That is the first thing. Second thing is pair of electrodes, anode and a cathode, are provided on either side of the channel at right angles. Again, at right angles to the magnetic field. So anode cathode is at right angles to the magnetic field, and the ionized gas is flowing right angle to the magnetic field. So we can use the um, thumb rule, right or left hand thumb rule, to get the directions. These electrodes are connected through an external circuit to deliver the power to the load. So the electrodes, cathode and anode, perform the same function as that of a brushes in the DC generator. In a DC generator, you have the brushes. Right, in a motor or a generator, you have brushes. You have studied all these things in electrical engineering. So this MHD system generates DC power. If you want alternating current, you may have to use an inverter. So usually the material of electrodes are graphite, and the duct through which the ionized gas is flowing is usually made up of boron nitride. This is a simple equation of the amount of power generated in a magneto-hydrodynamic system. Sigma UB square by P. P is the density, and replace that by rho. Sigma is the electrical conductivity of the ionized fluid. U is the velocity at which the fluid is flowing. P is the magnetic field density. Okay. So this much amount of power, we can see that the power generated is directly proportional to the square of the magnetic flux density. So however strong magnet you can use, you can have a greater power. So this is working in the block diagram. You have the fuel, it can be coal or nuclear energy or any other fuel, non-conventional or conventional fuel, which will be burned in a combustion chamber to release heat. Okay. The combustion gas will be allowed to go through an expansion nozzle so that the velocity will be increased at the expense of its pressure energy. Okay. Pressure will be really decreased and the velocity will be increased. You need to have a higher velocity. You have seen from the previous equation that the power generated is directly proportional to U, and it will be given to the MHD generator, and it will be generating power delivering to the external circuit. The exhaust gases will be given back to a heat exchanger where cooled air will be supplied. Air will be getting heated up, it will be compressed, can be used in the combustion chamber again. So the exhaust gas, the thermal energy from the exhaust gas is again utilized in the combustion process. Finally, after exchanging the heat, exhaust gas will be given out through the chimney. So these are some of the fuels used in the MHD system: coal, natural gas, oil, and nuclear energy. So there could be two different types of magneto-hydrodynamic system: open cycle and closed cycle system. In an open cycle magneto-hydrodynamic system, atmospheric air at very high pressure and temperature is passed only once through the magnetic field. So once that air from the combustion chamber is utilized, it is given out of the heat exchanger to the atmosphere back. It is not getting utilized. So there is a simple loop. Okay. So temperature requirement is pretty high, 2300 degrees Celsius. Open cycle magneto-hydrodynamic power generation system is more developed in the power generation. So this is the principle. As a block diagram, what you have seen in the previous slide also the same thing. The used air, that is exhaust gas, is given out directly. It is not being recirculated. Now coming to the closed cycle, the working fluid is recirculated in a closed loop. Instead of air, you can use inert gases, helium or argon. So we can have a less temperature requirement since the gas is recirculated. Still it is in the developing stage. You can see here the helium gas, after getting utilized from the heat exchanger, not given away, is given back to the cooler. Temperature is reduced, compressed, then again it is given to the thermal generation system where hot air is produced. So in this typical diagram I have shown a nuclear reactor. as a source, energy source. So there is a closed loop here, you can see. Instead of an open loop, we have seen a closed loop. So advantages of MHD system: higher conversion efficiency. That means the fuel is utilized in a better way than the conventional power plant when compared to a thermal power plant. Is having a higher conversion efficiency. There are no moving parts. So now mechanical wear and tear. There is a direct energy conversion technology. There is no intermediate stage. Operational cost is less, even though the initial cost is high. Operational cost is less. Why I said the initial cost is high? Because you may have to have magnet of very high strength and all this duct, nozzle, fuel generation. So once it is established, the operational cost maintenance are pretty less. Pollution. There is no pollution except in the case of power generation. For that you can use a renewable source of energy. And compared to the conventional power plants, the size is very small. One of the biggest disadvantages is the reverse flow, that is short circuits of electrons through the ionized fluid around the ends of the magnetic field. If you know the principles of magnetic field clearly, you can understand this easily. So whenever there is a magnetic field and some conductor is placed within the magnetic field, there could be losses. Say losses in electrical engineering or magnetism. So this will reduce the strength of the magnet, and it will allow the electrons to flow in an opposite direction, reverse direction, and the short circuits of electrons may or may not happen because of that, especially at the end of the magnetic field. And you may require large magnets, very high strength, as I mentioned, and the cost will be high. Now, having discussing about the principles, pros and cons, let us see the applications. So for driving submarines and aircraft, you can use this. Then, especially in wind tunnel testing, wind tunnel experiments, you can have this magneto hydrodynamic power generation. You can use this as UPS, uninterrupted power supply system. Then, for domestic use, you can generate power using imagery system because it is very small in size. Instead of establishing a power plant, you can have this to generate domestic power supply. So with that, we will end today's session. If you have any doubts, any suggestions for improvement, you're welcome in the comment box below. Please feel to contact me in case if you have any doubts or if you are interested to listen more lectures. Your suggestions are always welcome. If you wish to, have a lecture on any other subject related to mechanical engineering, you can comment below. I'll try to introduce that in the future. Thank you so much.